So thank you all for joining us. And our panel will be about one of the main topics I think that is crucial for everyone who's listening here, is about taking the research that we are doing in our lab, in our local machines, and make it into production. And this is something I know that many people are struggling and they have a lot of questions about that. So this panel is going to talk about those topics. And before we start, I wish we will make a short introduction. So feel free to present yourself. Amir, you can start.
Hi everybody, and thank you for inviting me. So I'm Amir. I'm coming from a background of machine learning, computer vision. Been doing that for the last 15 years. In previous startup, I was also the CTO, one of the founders, Broadman 17, did mainly automotive products. This startup, I'm the CTO of a company called Visual Layer, tackling visual data management.
Perfect. Ofer?
So yeah, hi, I'm Ofer. I'm coming from various background, mostly on engineering, but for the last almost 6 years, I've been at ZipRecruiter. I'm managing the data science and engineering team of the recommendations in ZipRecruiter.
Thanks. Gilad?
Hi, my background is also engineering, although I've been doing product management for the past 15 years. Also for software engineering and biomedical engineering. And in the past 5 years or so, I've been focused about ML operational side and MLOps, both in Iguazio and in the previous company I worked for.
Perfect. So thank you. And I will say that if you have any questions, the audience, you can share it in the chat or in the Q&A. We'll be happy to also get some questions from the audience. So let's start. And I want to start with a tough question for the beginning. And the question is that, what are the processes or methodologies do you use when you're developing a model that can be used for production? So basically the question is, are you working with some kind of methodology at the beginning of your work, your model training, that you know that later on this will help you to take it to productions, or just doing whatever you need in the research and then figure out later on how to make the adjustment to production? So Amir, do you want to start?
Yeah, gladly. So I find it personally over the years, working with a lot of researchers, the process has a tendency to diverge very quickly. So over the years, I found it very helpful to define what is the KPI. First of all, what is the product KPI we're trying to achieve? Once we have the KPI, let's say we want to develop, in my word, let's say we want to develop an object detector. So we need to understand what data we're trying to work on, what is the success criteria, like what is the precision or recall, and we need to decide on a specific metric. Let's say we want an accuracy of 0.99. And this will be the metric we will follow. So once we decide what data set we're working on, what metric we're following, everything afterward is very easy. And the language your team is using is unified. So once you get the baseline, doing iteration using agile, like working in sprints or any other methodology, is very easy. If you don't have it, I found it personally that people are very easily tending to diverge to different metrics, and then different people are working on other things, and the project or the product does not converge. Yeah, so this is the main thing, I think, for me.
Great. Gilad, what's your opinion on that?
It's very spot on. I completely agree. I think that beyond the metric, which I agree that's the first thing you need to do. What I've seen is that you need to take a production first approach, which means that the data scientist would be able to define their functions in a way that is later deployable to production in an easy way. Because if you just let them write code and not think about the actual deployment later on, it becomes someone else's problem. And this is even more difficult when you think about you have a lot of data processing to be done. So if the data scientist defines features and things like that, how would that later translate to production? That's difficult if you think about it only when you get to production. You need to break apart those logical components first, meaning what is your data processing, what is your training, what is your serving, make sure that you have a monitoring strategy out there. Don't wait just until everything is ready, and then think about how to get to production.
Okay, good. Ofer?
Yeah, so first of all, I think also that setting the metric and the business KPI is like the first key for success. And we do that as well. We use the same practice. I think also one of the things that help us is also identify the use cases and how the product eventually is going to be using the model or the feature that we're creating. That creates a lot of focus for the research team to decide on which kind of algorithm they can be using. So just for example, if you want to have something that serves an online prediction, then you probably won't try to use a very heavy algorithm or framework that will take seconds to predict. And that's like the focus and the use case and the collaboration between the teams that eventually are going to consume whatever it is that we're building is key to success for the project eventually. And that happens like very early on the project. Like part of the planning of the project is everything around it.
Great. I totally agree. And this will take me to the next question is that what kind of test or measurement do you do before you take a model to production? Because you can work with the best methodologies and do the best you can just before launching it. But do you have any metrics that you are, or maybe tests or validations that you do before uploading to the production? And then when it's already in the production, how do you monitor it? How do you just checking that everything is okay and working perfectly? Ofer, you are serving millions of users around the world and they are working with your tool in order to find jobs. So this is very crucial. So what is your approach in that?
Yeah, so I think there's like a many layer approach to testing the models. Like there's the validation test, which is part of the training itself. Like we can't get a model eventually if it doesn't follow certain patterns or rules on the validation set. And then there's like the test set that we use to validate whether the model is even ready for production, whether the metrics hold on a test set. And sometimes we use a gold standard so that there's like an agreed upon test set that helps us understand whether we have a model that is like basically ready to hit production. But on top of that, we use like various other methods for testing. Sometimes we use shadow testing, in which like we move traffic on the site to a model or service that predicts something, but don't change anything on the experience of the user, just to check the metrics in real time or collect data. But there's also the inference layer that we need to test, whether it holds the SLA for latency and memory consumption and everything like that. And I think the last layer is obviously A/B testing. So for many times in my team, it's very common that you can't really know whether the model will hold on production in real life use cases. So you just put a new prediction, a new model alongside the current experience, and just like measure the two for a few weeks, or depending on the amount of traffic, and until you have a very good read of the performance of the model itself. And if that works, then it becomes the control. Right?
Sounds good. I like the A/B testing approach. Gilad, what is your point of view? I'm sure that you got this question a lot from clients and all the companies that you are working with. So how do you help them find out what is the best way to be sure that the model is working best in production?
Yeah, I think to add on what Ofer said, the other thing is in terms of the integration, eventually the model itself is really a small part of the production system, especially of complex systems. To remember, it's you're kind of biased when you think about the research side. You're focused about the model, but when deploying, it's a part of a larger system. So you need to think about how does it integrate with the data itself? How do you make sure that it scales up correctly when you deploy it? You mentioned monitoring, so make sure that there is an output stream from the model to monitor the model performance and make sure that there is some kind of feedback loop that you can get back the information to the data scientist, especially if something doesn't behave as expected. There are also questions that you need to ask about the SLA, so that it's very different if you're talking about some internal application or something that works in batch versus something that is mission critical in real time. The rigorous testing that you need to do in one or the other is very different. And it can also vary between the different type of markets. So if you're in a very regulatory market, you might need to consider more about your testing and how to prove that the model actually does what you expect it to do and so forth. And if you're in a less regulatory market, maybe you have more freedom to release things and actually test them in production. This goes back to what we talked about in shadow mode. So you can deploy something in shadow that doesn't affect anything in production, or you can deploy it in a way that is A/B test or canary that affects maybe some of the users, but some of the users won't be affected and do it that way. So you really need to figure out based on your business goals and limitations, what can you do and the level of testing that you need to do.
Great, thank you. Amir, what just start, well, how do you approach that? I'm sure that you have a lot of experience from Broadman and also now with a lot of companies that have bad data and then later on understand that in production, all the bad data that they use starting to bite them. So what's your point of view on that?
Yeah, so I totally agree with the Ofer and Gilad. I think it's everything they said. I totally agree. Like once if you have the ability to monitor your model in production, I think that's best. And also if you're able to perhaps part of the data of the users to expose them to the new model and then do the A/B testing and so on. I think this is a great strategy. In my previous company, we did production models for automotive, like on embedded hardware, which were not connected to the cloud. So basically, we had to do a lot of testing and regression and offline testing and simulation and trying to estimate what will be the data, specifically the data the model will be exposed to. Because in a fixed static environment, I think it's pretty easy. Like it's hard, but it's very defined. You can define your environment and the test cases and use cases and make sure it's covered. But once you're exposed to real life data, things are starting to get a bit messy. So we had to do a lot of testing in order before we deploy the models, because once the models were out there, the only person that could tell us that something was wrong was the customer, and that's not that's not a very easy experience.
Yes.
These days, when we do like for Fast Loop, our project, we did so far more than 200 releases. And there we actually did a lot of regression tests. So once we did the coverage and basically we do a lot of model updates and code updates, as Gilad mentioned, the environment and the entire code is changing constantly. So we have a lot of regression tests, making sure nothing breaks. And once it's all okay, we launch it. And afterwards, we also have monitoring to see if anything goes wrong, so we can change it remotely. Yeah.
Perfect. So
maybe another thing to add.
Feel free.
There's also a question of managing the features. So if you have feature definition changes, you need to remember that it's not just about deploying the model. You need to make sure you deploy those features and maybe even backfill everything. Again, especially if you're talking about structured data. So I think that's another thing that you should consider.
Okay. Thank you for this addition. And now it took me forward to our next question. And I see also people are asking that in the Q&A. is about what tools do you use? It could be open source libraries, other tools. So if you have any concrete recommendation, thing that you must have used as part of your development and also taking the model to production, do you have any best practice for tools or methodologies you can share with us? Ofer?
Yeah, I just like, can you repeat the question? Like just something
I was
behind the door
asking,
that-
and this is the question also we got in the Q&A, so are you using, or what tools do you use that you can recommend, and you can say that we have
Yeah.
started to use that and it helped us, or maybe better understand our pipeline. So we'll be happy to hear your thoughts on that.
So yeah, on the development side, we heavily use Jupyter Hub for exploration and initial development of the model. This is where data scientists do their exploration of the data and like prototyping certain parts of it. We use Flight for orchestration and automation training. We use weights and biases, which is very helpful for our artifact as an artifact repository. We do experiment tracking with it and hyperparameter optimization. I think for the data exploration, we heavily rely on Spark to do like batch and data collection and backfill and on the serving side of like large batch jobs. And we just started experimenting with Ray as part of a feature store design. This should be interesting. We have a storage layer for serving. We use Elasticsearch for certain use cases. We use Data Lake, DynamoDB. We use Arise for monitoring the models. And we are building a feature store currently.
Cool. Amir?
Yeah, so my perspective is divided into two. So my previous company, we started in 2016. So there were actually pretty little, not too much out there in terms of tooling. So unfortunately, we had to build everything, and we are actually very excited. And we thought that was part of the job, like to build everything. We build the experimentation, monitoring, and the data store, and we basically built everything, including moving from Python to a real-time embedded and the inference engine on C++. So we built everything. That was a real pain, but it also got us ahead of the curve. I think today, when we are opening our new company, we are actually taking the opposite approach. We're trying to buy whatever is available out there. So I advise everybody not to try to build your own. So even if you succeed to build your own, and it actually takes you like 6 months ahead, you will not want to invest the time in maintaining it and like adding additional features and so on, because this is not your main focus of the business. You actually want to, let's say, focus on developing your models or your products. You don't want to build infrastructure. So we're trying to buy whatever is available. So we're just starting the operation. So we mainly use weights and biases for doing parts of the monitoring, and all the rest we're basically experimenting. Data management and so on. This is a very big issue and pain, and we're building this in-house because this is part of the product we're currently building. Yeah.
Thanks. Interesting. Gilad?
Yeah, I was smiling because I had exactly the same experience in the previous company Ofer as well. It was 2017, same idea. We need to build something, and it seemed like a relatively easy way to solve it. And at the end, we found that we invested too much time on the problem of deploying to production rather than focusing on the core business. And it's easy to underestimate it. And today, I work for a company that does those tools, that it is its core business. So Iguazio does focus on building tools for deployment to production. And we also created an open source called MLRun, which is an open source orchestration framework for MLOps, which is focused on deployment to production. A lot of times when you think about MLOps, it's about the development, but we see that the main problem is actually getting things to production. So it has a feature store and the ability to deploy to real time, and it includes the ability to build those building blocks for function training, for data ingestion, for training, deployment and monitoring, and integration with the CI/CD frameworks, and of course integration with other environments such as Kubeflow for pipeline orchestration and things like that. So I'm a bit biased because I'm
and Iguazio.
but that's our core business, to create that. And the reason we created this open source is to allow people who don't want to build on their own or start from something, work on that. So even though we have a commercial offering, I'm talking about the open source part, which purpose is to help as many people as possible.
Great. I know that we had some pre questions that we managed, but there's a question. There are several good questions in the Q&A section. I want to start with I think this is one of the interesting questions because a lot of people are struggling about that. Is question from Tsufi asking, as a data scientist, what would you say the scope of the data science work should be? Meaning, how much MLOps should a data scientist know and how much he or she involved in the MLOps cycle? And this is a good one because a lot of people are struggling and say, I'm just data scientist, I'm supposed only to make the research and let other people do the engineering, or vice versa. You need to know the entire scope because it will affect the research that you are doing. So, Ofer, what do your state of point on that?
Yeah, so first of all, I don't think there's like a single answer that will fit in every company. It's very, very individual. Sometimes different data scientists are more leaning towards MLOps and they will do it like easier than some engineers. And in other companies, it's completely the opposite. So generally speaking, you'll have to find your point in the team or your role in the team. What we do in Zip, we obviously struggle with a lot of MLOps related questions when we develop models. So first of all, we have a cross-functional team. So for our teams, the data scientists and the ML engineers are in the same team. They usually work together to build the product. So the engineers are part of the research, like up front. They're members of the project, and the amount of work and effort shifts toward engineering more on the end. And but they are complete partners up front with the project. So they generally find this like sweet spot where some of the MLOps is done by the engineers, some of them are done by the data science. We also have a team of ops, but for each team, it's self-contained.
Gilad, you see with the customers and companies that you are working, who are the roles that you are engaging with? Data scientist, ML engineer, MLOps. So what's your take on that? Who is responsible for this heavy lifting?
So generally, one thing that I think when I started, I had to probably explain the software engineers or the architects or the ML engineers is that data scientists are not software engineers. Again, generalizing, there are some that can do that, but most of them would like to focus on building the model, and we also like them to do that. And generally, I think that we need to give them as much freedom as possible not to focus on the technology and be able to develop their models and the pipelines without having to think about provisioning resources or what would be the integration with, if you have a Kafka stream or something like that, what would be the integration with that? Because if it's interesting for them, then fine. But if they don't want to deal with it, you need to give them the ability to do other things. That doesn't mean that they don't need to know how to write good code. They still need to know how to write code properly or how to work with Git or things like that. But everything about the deployment, preferably, it's not about just moving it to another person with its responsibility. It's giving them the tools that allow them to define what are those building blocks or those functions that they are using for model and for data processing and so forth. And then the ML engineer can take that to production in a very easy manner. Think about the process that we had in the past 10 or 20 years and deploying software. So 20 years ago, it took us many months to deploy software, and today we can do that in seconds. That's essentially how you want to do it. And so the way I equate it is you still have DevOps today who help you build those tools, but you don't need someone to do this manually.
Okay, I get it. Amir?
Yeah, so I think I agree. I think that depending on the company size and also the problem they're trying to solve, and also on the existing infrastructure. But if I need to make like a rough split here, so I think in small startups where you don't have a lot of redundancy, I guess any team member would have to be able to do a lot of the heavy lifting. Otherwise, she will find herself waiting for somebody else, and nobody comes usually. So they have to do the heavy lifting. In larger companies, I think where the engineering is a bit more managed and they already have infrastructure and working procedures. So I guess data scientists should do data science work. I also see a trend in, I think the trend will only grow, that we see that people, let's say, if in the past, in order to be like a data scientist, you had to have like a master's degree, you had to know exactly. So we see this entrance barrier getting lower and lower. And currently, I also see data analysts or people without any formal education actually doing excellent work using existing infrastructure and tooling. So I think in time, a lot of the infrastructure and tooling will allow the data scientist or even data analyst to focus only on the research or part of the development, and all the heavy lifting will be done by somebody else. So yeah. But if you're currently starting, like, you should understand, like, if you don't have the capabilities, perhaps a small startup is not the right place for you. Perhaps it will be overwhelming, but then again, it could also be a magnificent learning opportunity. Yeah.
Speaking of learning, and this is a question from O, is asking, and you said also about people, maybe data analysts doing this transformation, and I'm sure that the majority of you have done a lot of interviews and recruited a lot of people. So his question here is that, what is the best advice for you for someone that is starting his career in this field? Someone, for example, finished his advanced degrees and now is wishing he or she to get some more skills to become an ML or engineer or data engineer. So from your perspective, what do you see that is like the best criteria or the best tools that you can just advise people who want to enter this field, and from your perspective? Ofer?
Yeah, so the question is on an experienced engineer wanting to move to data science?
The question is about, let's say, a student is just graduate and is seeking to become an ML engineer and someone who's focusing on the MLOps. And the question is, how I interpret it, is that what are the tools or the knowledge or the skills that you see that will say, okay, I can give this man a try, or I can maybe just give him some tools, and then he will be able to make a value to our team. So the main question is, from your perspective and the people that you interviewed in the past, what could make the change? What could be valuable for you, for people that just in the beginning of their career?
Yeah, so in terms of ML engineering, for the way that we look at it at Zip is, like, these are engineers archetypes, right? So if you have an engineering degree, you are more than qualified to be seeking an ML engineering work. They are not data scientists, so that we don't require any specific research degree or sorts. But it does take a special kind of skill set to be looking at problems in certain aspects of the algorithm, and be able to communicate with data scientists in terms of understanding the algorithms, liking this entire ecosystem, so that you can take ideas and optimize them in a way that they reach production, like, with all the things that we said earlier, like the monitoring part of it, the understanding of the model, the understanding the frameworks. But other than that, just you need to be a good engineer and like the business aspects of it.
Okay, Gilad?
Yeah, I agree. First of all, generally, it's true for any kind of work. I think that first of all, you need to like what you're doing. Otherwise, it's very hard to survive. So especially someone who's starting, see that you like what you're doing, and you see, because if you don't enjoy it, it's not about, even if you're getting a lot of money, it doesn't matter. At some point, it won't help you. And generally, yeah, an ML engineer needs to know that working with data scientists, these are different people than an engineer, as I said earlier, and don't expect a data scientist to be an engineer. They might be, but don't expect them to be when you work with them. So learn the language, learn what they need, and see the best way how to cater for their deployment and how to get back feedback from them, and know and try to understand basically when a data scientist sees a problem with the model or with the deployment, what are they looking at? Again, the ML engineer won't become a data scientist, but the more they're able to speak their language and understand how they view the world, the easier it would be for them.
Thanks. Amir?
Yeah, I think that in these days, because of the fluid terminology for the different roles like machine learning engineer and data scientist and machine learning researcher and developer and so on, there is a lot of confusion. I think also different companies consider these different roles and responsibility for each job title. So if you're only starting, I would advise to specifically understand what you will do, like list it, like on my first day, my first month, what is expected of me to do. And this way you will be able to imagine if that's what you call a researcher or an ML engineer and so on. You will be surprised, I guess, sometimes for the better, sometimes for the worse. So you need to make this set of expectation. And also, if you're only starting, I would personally, I would love to see somebody much more senior than me in my team, at least one team member I can actually be very close to and learn from. I think this is critical, specifically for people just starting on doing the transition. That will increase my success criteria. Yeah.
Okay, thank you. And our panel has come to an end. So thank you all for this great session.